Okay, so up to this point, we have been, or at least in the last workshop, all of our data that we've stored has basically just been in memory, right? We've just stored our data as a JavaScript object, right? We've had the ability to modify that data, but it's never been persisted. In fact, you see that because every time the application ends up restarting, you end up getting a new random collection of data. So let's talk a little bit about what databases are, right? Two big pieces of a database are that it ends up persisting data, and the data is accessible, and it's going to be accessible via code that you're going to end up writing. In terms of it being accessible, it's going to be organized. We're going to find that it's organized in tables. We're going to find out that it's queryable through SQL statements, and it's going to be manageable from what's called a relational database management system, which is going to end up managing our databases. So data in SQL is organized. Your database itself is going to be a collection of tables. Now, some of these terms are mean the same thing. What is that? Synonyms. Yeah. Synonymous. Very good. Okay. Some of these terms are synonymous. So sometimes tables are called relations. Okay. Tables have columns. Sometimes these columns are called attributes or fields. The rows would be called instances or sometimes tuples. Okay. Duplicate rows are not allowed. And rows often, almost always, end up having a primary key to identify a row. So if we end up looking at some data here, we could see here would be a simplistic table or relation that has both an ID, which is going to be a name, and also, has an ID, which is going to be an integer, and there's also an attribute for name, and also an attribute for type. So you see these different expressions and how they end up, these different definitions, and again, how they're synonymous. Also, you see that, one way to sort of think about it is that if you remember back to foundations, when you had constructor functions, so you had this function called person or mammal or animal or something like that, and you could instantiate a new one. You could sort of think about that as being a row in a table, okay? The table is going to determine the structure of what you instantiate, the same way constructor function determines the structure of what you end up creating, okay? Sometimes we call those constructor functions templates for that, right? So what we're going to find out is that the table itself is going to dictate the data that you can end up storing for each of these rows. So just a little bit of history with this stuff in terms of where it started. Ends up starting at IBM in the early 1970s. So SQL itself was sort of the first commercial language. This guy who's sort of the father of all this stuff, a guy by the name of E.F. Codd, who ended up, I guess, really inventing what the relational model, or how these things should work, without necessarily coding it. He ended up describing it. In terms of, so this ends up getting developed at IBM based on E.F. Codd's relational model. Later on in the 70s, there's this company called Relational, and they developed an RDBMS. They ended up becoming Oracle. That was sort of the first really big player in this. One of the other things that happened is that different database systems had different ways of querying data, which got to be a real drag. We'll find out there's something similar when we go into browsers and look at how browsers end up not necessarily being compliant. So one of the things that made a big difference is that SQL became standardized in the 1980s. And this, I just like to put this in because this guy Codd was so famous. So this actually describes, there's different forms of normalization. And one way that people remember this form is that you have to have the key, the whole key, nothing but the key, so help me God. So I just like that quote. So one thing about databases is they have to be queryable. You have to get your data. One of the things that we'll find out is that they're declarative. What does that mean? Well, our data is stored in this database, okay? We access it through a DBMS, a database management system. We don't say, hey, look, how to get this data? How do you end up getting it? What do you end up doing to get it, right? We leave it up to the database to make some decisions about how it gets its data. We are declarative to say, hey, look, we want to get the data from this table. This is the fields that we want to get. But we let the database management system do the work of actually getting the data for us. So the DBMS is going to basically pick an efficient strategy. We could make that strategy a little bit more helpful by doing things like adding indexes on certain tables. If you remember when we spoke back about binary search trees, right? These actually end up playing into databases by saying, hey, look, here's this field called email address, which we're going to search on a lot in this table. And so we might end up creating an index on that email address. You don't get something for nothing. That ends up adding some overhead to things. But our database management system will go, oh, you want to look by email? I'm going to use this index that you gave me. Remember how fast we could end up getting data when we had something like a binary search tree? We could get it in log n time, which is pretty remarkable. In terms of what our SQL looks like. So here, what we're doing is we are selecting from our table. Our table is Pokemon. Now, just in terms of how things end up getting named, normally databases, the tables will be pluralized, right? So this would probably be Pokemons. Maybe that looks a little bit silly. Here we have a where clause where we don't want to get all the data, but we just want to get this specific type. And this is just some syntax that says we just want to get one record back. These are all things that we're going to end up exploring. So the reason why you end up, more than anything else, I mean, if you look and say, man, I don't really want, why do I have to deal with this database management system? I know what my data is. Why don't I just take my data, I'll stick it in some different files, I'll have my user data in my user file, I'll have my product data in another file. When I need to get the data, I'll end up reading from the file. Well, what ends up happening is that the database is going to handle, this database management system is going to handle a lot of things for you. So it's going to, first of all, make sure that your data is in a consistent state. You're going to be able to specify different rules about your data, okay? What is required, what's not required, what types of data could go in here, what data types can end up going in here. It's also going to, under the hood, if in fact there's multiple requests that are going on to a database management system, it again is going to handle the process of any threads or that sort of thing. This is not something that we have to worry about. So we end up accessing databases from a database management system. Usually we end up using relational databases. So usually we'll end up seeing, you'll see RDBMS, Relational Database Management System. So one of the reasons why you have to appreciate databases is that they're all over the place. Okay? Very, very common in application development for persisting data. Odds are you're going to be working with a database, and odds are, for the most part, that you're going to be working with a relational database. There are some databases that aren't relational, but these seem to be the most prevalent that you'll end up running into. So also the other thing is that, even with different database management systems, a lot of these query languages that you're going to end up using in terms of your SQL is going to be standardized among them. And the fact is that even with these tables, you can really create complex structures. Really what it ends up coming down to is complex data structures that reflect whatever your application is supposed to do and enforce that within the database. So let's take a look at some examples of this. So right now we have, if you looked at this, what we have here is we have a student table and we have an addresses table. Okay? They're both pluralized. One of the things that we see here is that, now again, I'm explaining to you, this is how this particular database would be set up. You couldn't necessarily make that, you could make an assumption, but you wouldn't be sure until you ended up looking at what would be the schema of a database. What we have here is we have students, and every student has an address. Okay? But you'll also notice that addresses can be shared by students. Okay? So if we look at the address table, if this was all the data that we had, one of the things that we find out is that not all of the addresses would end up getting used here, okay? But every student does have an address. So one way that we sort of think about that is that if we sort of think about the relationship, we would say that a student has an address, okay? An address can belong to many students, right? The address can end up getting used. So we're going to see this relationship, these different relationships. We'll go into it in some detail. So if we also wanted to go in here and we wanted to basically just look at, we wanted to do a query, but we wanted to do it based upon students that were 20 years old, right? So what we want to do now is we want to limit our results. Here, this becomes a pretty easy thing to do. And the reason why this becomes an easy thing to do is that all the data that we're looking for and all the conditions are based on one table, okay? So this becomes a pretty easy query to run. We could run it, and what we'll end up doing is we'll end up getting a result set that'll just have the name and the ID of the age, but the result set is only going to have the students that are age 20. Now things could get a little bit more complicated here. If we wanted to get the students with their particular addresses, things get to be a bit more complicated. And the reason they get to be a little bit more complicated is that you have to specify how the joins are working in this database. And so the first thing that I always like to do is to figure out what's the data that I'm going to be looking for. So one of the things is, if you wanted to get this result set with the ID of the student, the name of the student, the street, the zip, and the city, you could think about what tables you need to query from. If we end up looking at what that query looks like, you could see that we're going to get the student's ID. And the fact is that since we're going to be getting data from two different tables, and since there's an ID in both tables, we have to be specific as to which table we're getting the ID from. So here, we're getting the ID from the student's table. We're going to get the name, the street, the zip, the city from the student's table. And the fact is that since some of those columns or some of those attributes are in another table, we've got to do a join. So we've got to do a join from the student's table to the addresses table. One thing that would be a little bit more common, instead of calling that attribute address on the student's table, odds are we would probably call it address ID. It's a little bit more descriptive. It's not really the address, it's the ID of the address. We couldn't call it ID because we already have an ID there. So this gets to be a little bit more complicated because we're doing the join, and if we wanted to go a step further, we could say, hey, look, we also want to filter that data, right? That's what the where clause does. So the join is allowing us to join our different tables or relations. The where clause is allowing us to filter the data, and the select is allowing you to get the data that you want. In terms of the things that you're going to end up getting familiar with in this workshop, a couple of keywords that we have with SQL. You've seen select, right, which tells you what columns that you want. You've seen from, this is really where you're going to get the data from. You've seen join because we need to sometimes get data from two different tables. The on allows us to specify how we're joining the two tables. And the where clause is allowing us to do a filter. The thing that I added here, and I'll show you an example of, because you'll see it in the workshop, is sometimes you want to group data together. And sometimes when you group data together, you want to filter it after that. And that's where this having comes in. So what ends up happening with, when we talk about the difference, and we'll go into a little bit more details about this in the next workshop, not this one, but the schema itself. The schema itself is really like the template for the data that's going to go in the table. Right? When you think about the schema, I would say the schema is really describing what the constructor function is. The schema says, here's this table. It's got an ID that's a primary key. It's got a first name that's a string. It's got a last name that's a string. It's got an email that's a string. The email is required. There's also a foreign key that's related to this table, right? That's what the schema ends up describing. and the schema can end up getting used to validate the content. So there's a difference between the content and the schema. Again, one way to sort of think about it is that the table dictates the schema, and the individual instances in that table, or the rows, or the tuples, right, they're going to be the data themselves. So there's a couple of cartoons about, if you had a loaded table and you wanted to start entering queries, right, you could end up selecting different information to get the queries, and you could find different things about people. The thing is, if you decide that you want to drop the table, which you could do, then all of your people just end up vanishing. So not only can you end up selecting things, right, but you could also end up basically just wiping out a table by dropping the table as well. So when we think about SQL, we'll think about CRUD operations. In terms of CRUD operations, we're going to be inserting data, we're going to be selecting data, updating data, and deleting. So why is it CRUD? Well, CRUD is really create. Instead of insert, we could say create. Select would be reading. Updating is the U, and D would be deleting. The other thing so these are actually all keywords that we're going to end up using when we end up writing SQL statements. And we also have the ability to write SQL statements that'll create our schema as well. So let's look at an example of this. So this is a little bit more complicated. What this says is that you've got two entities. And again, when I look at something like this, I like to focus on the things that don't have the dependencies. What I mean by that is I can think about schools on their own. I can think about students on their own. But I can't think about enrollments with without both of those things, right? So schools, pretty simple. They have a name and they have a level. A student also has a name. They also have an age. They also have a gender. There's primary keys for all of these. The enrollment table would be considered a join table, okay? And what it's a way of doing is to really say, hey, look, a student belongs to many schools, and a school can have many students, okay? If a student only belonged to one school, you wouldn't need a join table. You would just put a school ID over here, okay? But maybe there's some reason why you want to have these enrollments. Would probably make a little bit more sense. Maybe if there was another field on the enrollment table, might be a school year or something along those lines, which you could end up doing as well. But this enrollment would be considered a join table. Sometimes you'll see things named a little bit differently. One of the things that sometimes is done is you might call it student schools, you might call it school students. It's joining these two things together. So join tables work, in this case, this is a join table, specific join table. They work for many-to-many relationships. And again, what this allows us to do is that we can say a student has many enrollments, a school has many enrollments, but on the same token, for a specific enrollment, okay, an enrollment belongs to a specific school. One enrollment belongs to a specific school. One enrollment belongs to a specific student. So that's what the relationship between these things are. So if we wanted to end up selecting something, we could select data from the student table where the age is greater than 12. This we've actually seen before, right? We could actually determine what data we want to end up selecting. Little SQL joke you could use at some point. It's a good one, right? So a more interesting select is that, let's say you wanted to find all the students from Springfield Elementary. Well, you can't do that from just the student table. And you can't do that from just the student table. This is one where you're really going to have to start doing some joins to get this data. So the way that you're going to end up having to do this is that you're going to have to basically do a join, right? And you're going to have to specify, hey, look, you're doing a join on this enrollment table, and the student ID corresponds to the ID of the student table. The school ID corresponds to the ID of the school table. And your query is going to end up giving you this join of all this data. And then once you end up having that join, then you can decide how you want to end up filtering it. So the join basically is what it's doing is it's going and it's joining this data in rows, and then you have the ability to filter it. One question that you might ask, and it's worth asking, is, why not, what do I need these separate tables for? Why don't I just store this all in one table? And the fact of the matter is that you could. The problem with that is that you have a lot of duplicated data all over your database. So if you stored this in one table, you'd be storing the string Springfield Elementary on every single row in that table. And that's fine. It could be good, but if I decide then I want to change the name of Springfield Elementary to something else, I've got to do it for a bunch of different rows. If someone ends up misspelling Springfield Elementary, I'm in trouble. So the fact is that when you end up breaking things up into different tables, this is called normalization. Okay? Putting them back in the same table is called denormalization. But breaking them apart, what it allows you to do is keep your data a lot cleaner. Let's talk about a couple of different joins that we could end up using. So what we've been talking about so far are these joins that gives us an intersection. Okay? So when you say select from A, inner join, that's just the same as doing a regular join. When you say select from A, and I want to do a left join, what it'll do is it'll give you all the records from A, okay? It'll give you all the records from A, even if you don't have a join in B. Well, I'm going to go over some examples of this so you could see it. The full outer join would get you from both sides of the relation, and the right outer join, which frankly is not even supported in MySQL, which we're going to look at, and you can actually get to this by just changing the order and doing a left join. You wouldn't really have to do it.
Is the reason that we have all these different joins instead of just doing an outer join and selecting all you want speed purposes would be cumbersome?
No. The reason why you end up doing, so in other words, why there are different types of joins?
So, for example, if we did an outer join, but then selected the columns that we wanted, we could potentially get to the same thing as the inner join.
Maybe.
Or is that actually?
I don't know. You know what? I don't know the answer to it. I'm not sure the answer to it. I think you're right. I think there might be something to the optimization by putting the where clause there, but I don't know. I have to be honest with you. I don't think I've ever used a full outer join in my life. This is common. This is pretty common. Let me just get through this, and
Sure.
we're gonna, because or else we're just gonna go a little bit too long. But if you have questions, just hang on to them. So here's an example of two different tables. All right. So if we just sort of looked at this data here, what we could see is that in our pets table, all of our pets have owners, except our lizard, Carol, right? Our lizard, Carol, doesn't have an owner. And we could also go over here and also make the case, not make the case, but see that each of our owners has a pet, except data, okay? We have no owner ID for 3 inside this table, okay? So again, depending on what we want to get with our results set, this is why we might end up doing different joins. One of the things that ends up happening here is that if we end up doing an inner join is just a regular join. An inner join ends up giving you the intersection, okay? So here, we're doing an inner join on our owner's table, okay? But notice that we don't get back, we lose our owner number 3 in the result. The reason why we lose our owner number 3 in the result is that he's got no match in the pets table, okay? If it turned out that we wanted to have all of our owners as well, okay? We wanted to see that we would have an owner without a pet, we can end up doing that, and that's where you would end up doing a left join to get that data. So here's an example of doing that. So now, in this case, if we end up making this call, what this is going to allow us to do is that we would be selecting now from our pets and our owners, okay? And in this case, the fact that we're doing a left join, what we're saying is, hey, look, okay, even if we don't have a match, okay, even if we don't have a match for the pet, we want to get this owner. And the result will be that we're going to end up having a null value here. Okay? This would allow you to do things like find out the owners that don't have any pets or that sort of thing. But anything you can do with a left join, you can also do with a right join as well. And again, this is getting our null data here. Our right join is just the same thing really in reverse, where in this case, what we end up doing is that we're going to get all of our pets even if we have a pet that has no owner. And the fact is that we can get the same result by just doing from pets and doing a left join to owners. It would end up getting us the same result. And again, some of the relational databases will even make you do that, which I found out from SQLize. Full outer join gives you all of your data with all the nulls, and again, not all database engines support that as well. And so here you see one with an owner name of null and one with a pet's name of null. Now, before we dive into the workshop, let me just show you one thing that I thought was pretty helpful, for me at least, is that I've got just pop this up. Okay, so what I'm going to do here is that if I open up this is a SQL script. Next, let's see. I think I have one that's a little bit more. Here, let me go one more level in. Sorry. Okay. Okay, this is a little bit more detailed. This has a many-to-many. And I also wanted to, see, I think I have that open twice. Kill it. Okay, so let's just take a look at this. What this allows me to do, first of all, when we end up using SQLite, one of the things we could do is we could open up SQLite and basically just run queries. But the other thing we could do with SQLite, after you install it, this is what you're going to do in the workshop, is I could say SQLite, I want to use this database, and I want you to basically read the following script file. Okay, so it's going to run this script. SQLite 3. Okay, so you're not seeing all that meaningful data here. Let's go in and take a look and see what that does. So what I'm doing here is I'm running this script. And what this command does is it says, and SQLite is actually very nice to you. SQLite says, if I don't find a database called Acme SQLite, I'm going to go and just create it. Okay? And I'm going to execute this script that you're putting here with the less than symbol. So when it ends up running this script, a couple of things that I'm doing here. I wanted to demonstrate a many-to-many relationship. So here's a table of users. Okay, so one of the things you can do with SQL is you could end up creating a table. And the one thing that I want to do is that I'll get an error if I try to create that table and that table exists. So I've just got a little logic up here that says, hey, look, if any of these tables exist, if they exist, drop them. I want to start off from scratch. This is pretty standard SQL. I'm going to create this table of users, and basically what I'm doing here is I'm setting up my attributes. Okay? And I did actually did this a couple of different ways. So I have users, and I'm saying a user is going to have a primary key, a user is going to have a name, and I'm also saying, hey, look, a user is going to have a product ID. Maybe this would be the user's favorite product. We could think about it like that. Every user has a favorite product. Maybe this user is the manager for that product, whatever your business model is. products table is very simplistic, right? The products table only has a primary key and a name, okay? The product users table is our join table. That's the equivalent of our enrollments table. And what I'm able to do is actually create this by specifying, this is something you'll do in the workshop, is that I'm giving it a primary key, and I'm saying that a product users has both a product ID and a user ID. What I'm doing there is I'm specifying that a user can have many products, and a product can have many users. What would maybe that be used for? I don't know, maybe a shopping cart or something along those lines. Once I have my data table set up, I'm going to write some SQL statements in here that end up inserting the data. Right, so I'm going to have products of foo, bar, and baz. And just for the sake of being interesting, I'm going to go over here, and there's no law that says that every user has to have a product ID in the user table. So I said, hey, look, Mo's the only one that I'm going to give a product to, and I'm going to give the value, I'm going to give him foo. Now, these become a little bit more interesting, because what I'm actually doing here is I've got my products, I've got my users, and with this line over here, I'm basically saying, hey, look, Mo has a foo, right? And the reason why I know this is that by default, at least with SQLite, is that the order of your IDs is going to be the order that they end up going into the table. So I'm cheating a little bit. And I'm going over here and I'm basically saying, hey, look, Mo has a foo, right? Insert into product users, and the way that you end up inserting is to specify the fields that you're going into, and then you specify the values. Notice also all these SQL statements end with a semicolon. This is you're going to see in the workshop as well. I'm also saying that Mo is also going to have a bar, right? Product ID, user ID, Mo also has a bar, okay? And just for the sake of doing something a little bit different, I'm going to say Larry is going to have a foo as well, right? Foo has an ID of 1. Larry was the second one we put in here. He's automatically going to get an ID of 2. And again, this is just how at least SQLite is set up. Every time I drop the table, it's going to basically give me primary keys in order. Now, what ends up becoming kind of interesting for some of these things is that, let's just comment this out. And let's go over here and sort of demo some of the things that we ended up doing from here. Let me actually do this. Okay. So what I'm doing here is that if I go over here and I go and I select from products, right, left join users. And let's see what the result is. Okay? So one of the things that I find out is that what this is doing for me is this is saying, hey, look, even if products never end up showing up, right, left join users, right, I get the products even if there are no users that are associated with them. If I just did a join, right? If I just do a join, the reason why that happens is that if I just do a join, it's going to say, hey, look, where is there a connection between these two, right? Again, don't forget that this is my users table, and the only user that actually has a product is Mo, right? So again, what this allows you to do is specify, hey, look, if you saw those circles, if I say left join, right, I get the other products, even though there's no user that's associated with them. I think what becomes a little bit more interesting here, and this is something that you're going to look at in the workshop, is that one of the things that I have the ability to do is to basically, a lot of the queries are going to end up doing this. One of the things that you have the ability to do is to aggregate data, okay? So there are certain things in SQL that allow you to aggregate data. What I'm doing here is I'm basically saying what I want to do is I want to look at product users. I want to join it with users. That seems reasonable, right? I've got product users. I want to join it with users. The join is on the user's ID and the product user's user ID. Okay? What I want to actually do there is I want to find the number of products that each user has from that table. And what allows me to do this is by saying, hey, look, I want to group it on the user ID. What this allows you to do is to basically take a result set. The way that I like to think about it is it takes the result set and it says, I'm going to take everything that has the same user ID and I'm going to put it inside one bucket. Okay? So we'll take all, in our case, it's pretty simplistic. All we have really is Mo, who's got 2 records. We've got Larry that has 1 record. So you can sort of think about taking a bucket and labeling one with Mo's ID, labeling the other one with Larry's ID. And usually the reason why you want to do this is you want to count something. Maybe you want to sum something up. Maybe you want to get the max value. Maybe you want to get the min value. But counting is something that's pretty common. When I end up doing this, what I end up getting, not surprisingly, and let me comment this one out. So if I end up doing that, what I'm going to end up getting is that I'm going to find out that Mo, that first value is the count. Mo has 2 products through that user product table. Larry only has 1 product through that user product table. The thing that becomes a little bit complicated is that, let's say that what I was interested in was that I wanted to find the users and I wanted to find the number of products that each user had through that user products table, but I was only interested in the users that had more than 1 product. You can't do that with a where clause, okay? You can't use a where clause after you end up aggregating things together. This you'll end up covering in the workshop, but this is just something to realize. That's where, if you remember in that slide, I put in having. And this now allows us to go in and say, hey, look, we're interested just in the people that end up having 2 products. And if I went over here, if I said greater than 0, I'd have both of them back. If I went over here and I said greater than 2, I'd have nobody. So all I wanted to do here, and I have this saved up as a gist, I could send it out to you, is also just to show you how you can end up using SQLite, which you're going to do in the workshop, specify the name of a database, and specify a file that you're going to run. That's the other thing that I think is worth seeing.
How does having and where differ?
Where you could end up doing once you end up aggregating, you can't do where clause after that anymore. So the having ends up allowing you to basically doing a filter. Okay. Once you've ended up grouping things together.
Before you group, you use where.
Before you group, you would end up using where. Okay. Any questions? I know I saw some hands go up before. Go ahead.
I have a question. So, what's the structure of the data under the hood? Because we keep clearly the table is an abstraction for something that you showed an object earlier. Is it a nested array? What is it?
I don't know. I mean, it depends on what the database management system is. It's a good question. I don't know the answer for you. And I really would have no reason to know that. There really would be no reason for me to know how the data. I mean, I'm not going to store the data better than a relational database management system is going to store it. That's why I'm using a relational database management system. So if I wanted to write my own RDBMS, I guess I would be concerned about how the data is stored under the hood.
Well, I guess what I'm curious about is, like, in the last workshop, you had a data file, right? Where you just had arrays and you had functions and whatever. Okay, cool, that's your data. And then now we're kind of looking at the different kind of data, right? Like through interacting it through this relational database.
No, let's be clear though, right? What we're looking at is a relational database management system that gives us the ability to persist data. How that data is stored under the hood is, again, it's an interesting thing, but I don't think it's all that important at this point. I don't know why it would matter.
I guess if you wanted to write could you theory write a function that takes certain pieces of these tables?
Yeah, but you'd write it with a SQL statement, and your relational database management system would know how to optimize that to get at the underlying data.
Oh, so you would use this within, you would use the relational database management system to write a function. So
To write a query.
To write a query.
Uh-huh.
Okay.
The language of interacting with an RDBMS is queries.
So it has like a lot of the same like methods that we have for, I guess, operations.
It's a very limited vocabulary. I mean, it has the language that you saw before, and then maybe some other keywords. So it's pretty limited. Okay. I mean, the question is the important question, and we will cover this, is that how do you end up? What are ways to make your schema to make them so that they're optimized for what you want to do? But that's really a different question.
Sorry, how would we get this into the JavaScript environment? As we got it.
Oh, that's a good question. So the question is, how do we get it in? How do we get it into the JavaScript environment?
Yeah.
Okay. Right now, it's not. Right now, what we're doing is running a SQLite process, which is running a query. The way that we would end up getting it into a JavaScript environment is that someone is nice enough to write a node package that interacts with the underlying SQLite commands that are going to allow us to execute those commands within a node environment. Okay? The same way that when we end up moving to a different database, which is a Postgres database, someone basically will have written a wrapper, okay, in Node around Postgres that allows us to interact with Postgres. In this workshop, we're not doing that, although there is some of that for the extra credit of the workshop that you might end up looking at. So there's a Node package called SQLite 3 that'll allow you to interact with the SQLite database. But there's a lot of queries to write before you end up getting to there, and I think most people don't end up getting to that. Any other questions? No? All right. Let me pair you folks up.